Bismillahirrahmanirrahim. Test of significance. In test of significance, we compare the values calculated from our own data using appropriate equations with values in the table for the same number of degree of freedom. This identifies the alpha value for our experiment, which is the fractional chance that our result could have arisen merely by random error, and x bar and mu, or x bar 1 and x bar 2 are not truly different. This is in two sample size, and this is for a single sample. Compare the mean of the samples with the mean of a population, a total population. The alpha values refer to one tail of the distribution only. If we are interested only whether T alpha is positive or negative, this is a one tail test. T alpha is positive or negative. No positive and negative. This is a one tail test, and the chance probability is alpha. Example for one tail test are when we are seeking to increase the yield, or a reaction rate of a process, or to decrease the costs. Sometimes we have to use two tail test. Because both sides are important. For example, when we investigate whether a new analytical method gives a mean result different from that of an established method. This method, for example, method 1, is different with method 2. For example, the yield of reaction of method 1 may be less than method 2 or greater than method 2. This is two-tailed test. Choosing a one-tailed test were legitimate halves the chance probability and consequently increases the likelihood of our observing a significant result. This is an example for 95% confidence with 5 degree of freedom, we need TAE is equal to 0.02 on a one-tailed test, or TAE is equal to 0.75 on a two-tailed test. I'm going to demonstrate in this table. In this table, with a range of degree of freedom 1, 5, and 10, for this number of alpha. In one-tailed test, the probability level for one-tailed test is 10%. And mean the confidence of 19%. But for two-tailed tests, this is 18%. And the probability level is 20% probability. And this is for 95% confidence, and for two-tailed tests, the alpha 0.05 is for 90%. Because the alpha is equal 1 minus confidence divided by 100. And this is percent, 95%. The probability level is 5, 2.5, 10, and 5%. It's due to degree of freedom. For example, for degree of freedom 1, this is 3.08, 1.48, and 1.37, 6.31, and this is 2.02, and this is for one tail test, and for two tail tests 2 alpha is equal for one tail test. The percent of probability level is alpha multiplied by 10, and for two tail test this is 2 alpha multiplied by 100. These so-called critical values of t are connected with the need to distinguish between highly significant or less significant. For highly significant, the probability is less than 1, means 99 over 99% confidence. Degree of significance, and this is probability percent. For significant that is for statistical aspect, the significance is between 1 to 5 probability, or 99% to 95%. This will can tell about significant in statistics. When the degree of significance is or the probability is between 5.1 to 10, it is possibly significant. For determine the significance, we would continue testing. If it goes down of 5, that is significant, and the probability when is greater than 10, or below 19%, that called it is not significant. Use of the normal distribution table. If we already have so much information that we feel we know the population mean, mu. The population mean is known, and the population standard deviation, we can proceed as we did in previous examples. This is often the case in quality control work where a large amount of earlier data is available. Example, to test whether a single observation could come from a normal population. Many batches of a product have been made in a chemical plant, and it is known from this long experience that the combined water in the product is distributed normally with mu equal 2.48%, and the standard deviation of population sigma is equal 0.12. After necessary repairs to the plant, a single test on the next batch give 2.76% moisture. Therefore, UAE is equal x minus mu divided by sigma is equal 2.76, the moisture minus 2.48% of moisture divided by 0.12 is equal to 2.33. From a normal distribution table, we have this number 1 with probability of 90%. In the normal table, this is 2 point and for probability or alpha of 0.9 with is 2 point, because this number is between these two numbers in normal distribution table, there is only 2% chance that moisture content being found as 2.76 without repair having caused some variation in the product. Therefore, the difference is significant and there is only a 2% chance that this difference is caused only by random error. Note that we have used two-tailed test probability level because we did not state in advance that only result higher or lower than before would be of interest.